Hello. In this short video, I'd like to offer some support and tips concerning the Chem 121 lab, and in particular, the Chem 121 labM. So this is entitled Calculation Tips for labM. Now, the reason why I'm offering this is because I find that sometimes students will get off on the wrong track when they start to do these calculations. And of course, if you're on the wrong track from the get-go, then you'll not likely arrive at the correct answer in the end. So I'd like to remind you that what's happening here is there's a reaction between persulfate and iodide. This is the reaction of interest. We want to find the order of the reaction with respect to the persulfate and the iodide. The way that we're monitoring the rate of reaction is we're looking for the production of iodine. The way that we detect the iodine ultimately and determine a time is the fact that we use a second reaction involving thiosulfate, a limited amount of thiosulfate. And as soon as all the thiosulfate is consumed by the iodine that was generated in the first reaction, there will be an excess of iodine. At the point that there's a slight excess of iodine, this iodine reacts with the starch in the solution and we see a blue color. So for each of our experiments, it is always the same amount of iodine that is being generated. What will differ is how long it takes for that iodine to be made. So in terms of doing the calculations and also doing the experiment, a number of systems have been set up. So I will talk you through what's involved in doing the calculations for System 1, and then, of course, you can apply it to the other systems. So in System 1, we're adding 10 mils of the 0.2 molar iodide, some starch, of course, 10 mils of the 0.0050 molar thiosulfate, 10 mils of the 0.1 molar persulfate. Now, the final volume of our solution is 32 mils. So the concentrations that you see listed there are the stock concentrations. These are not the concentrations of these various components of the reaction at the time zero of the reaction. Because, of course, if you take 10 mils of the iodide solution, 0.2 molar, and you dilute to 32 mils, the concentration of the iodide, of course, will be less than that 0.20 molar. So what we need to do is calculate what is, and we'll call this the initial concentration of the iodide, the initial concentration of the thiosulfate, and the initial concentration of the persulfate. So in the next slide, I show you from page 33 that in terms of putting in our data, we're going to want to put in, well, what are the original concentrations of the stock solutions? And then let us say that we do an experiment involving System 1, and for instance, the time for the iodine to be produced to use up the thiosulfate and then the blue color to appear is 92 seconds and 94 seconds. So that'll give us an average of 93 seconds. So we'll keep that in mind. And then the idea is that we want to complete this chart for each of the different systems. And we're going to calculate the concentrations of iodide, persulfate, and thiosulfate at time equal to 0. To help you do this, I'm going to take a portion of this table and a portion of the table that shows you each of the volumes that we used and put those two together so that you can see how they work together. So here's table 1 with the various volumes of the solutions that we use. Here's table 3, and where we're going to fill in the line for System 1. Now, to calculate the iodide concentration, the idea is that we understand that we're going to take 10 milliliters of a 0.2 molar solution, and from there, actually, we can calculate the moles of iodide that have been added, and then dilute that to 32 mils. Now, we can write all of this like this. So 0.20 molar times 10 mils divided by 32 mils. Now, technically, if you are multiplying a volume by a concentration in molar, well, then the volume should be in liters. But the fact that the final volume here is also in mils and the units will cancel, it's just a very convenient way to do a dilution calculation. So we should then plug in that 0.062 for the concentration of iodide at time equal to 0. In a similar fashion, when we look at persulfate, here it's 0.1 molar because that's its stock solution concentration. We also took 10 milliliters and we dilute to 32 mils, and that gives us a concentration of 0.031. And there we put that into our table. For the thiosulfate, 0.0050 molar, again, times 10 milliliters, divided by 32 mils, and there's the concentration of 0.0016. Now finally, we need to determine what is the iodine concentration that is produced at the time that we see that blue color. That is, what is the amount of iodine that needs to be produced to use up this quantity of thiosulfate? So here I show you in the next slide. So I want to remind you that for every 1 mole of iodine that's produced, 2 moles of thiosulfate are required. So if we want to calculate the concentration of iodine, essentially we can do sort of like a mole bridge conversion. Now I realize that normally when we work with mole bridges, we want to be working in moles, but you can also do this in terms of concentrations. So if we found that the concentration of thiosulfate that's present in solution in those 32 mils is 0.0016 molar, we can use this conversion factor based on the balanced equation, 1 mole of iodine per 2 moles of thiosulfate. Now that I've got the 0.00080 molar, I'll put that into my table. So that's the concentration of iodine that needs to be produced in order to consume all the thiosulfate that's in solution. And that's when we clicked our stopwatch, so we have a time associated with this. Now, in fact, this represents a change in concentration, because the idea is that originally we had 0 concentration of iodine, and this amount was generated. So this is the final concentration, and subtracting out 0, well, when we end up with this number. The time it took, in this particular case, we saw was an average of 93 seconds. So the initial rate can be calculated as the change in concentration of iodine, 0 to this 0.00080 molar, and the delta T, 93 seconds. So this comes to 2 sig figs, 8.6 times 10 to the negative 6 molar seconds to the -1. That's our initial rate for these particular conditions. So the idea is that you just need to repeat these calculations in terms of the various concentrations. Now, one of the things that you're going to notice is that, for instance, in system 2, we essentially dilute the iodide concentration by 2. So the next concentration is going to be 0.031. We keep the persulfate concentration constant. So that's the same. Note that the thiosulfate concentration will be a constant for all of these experiments because we always put the same amount of thiosulfate. Therefore, the amount of iodine that's generated will also be the same. So every column will have the same number. Of course, the initial rates will be different because there will be different times by which this iodine is produced. Or at least we're going to expect that. You'll have to see what you actually end up with in the experiment. So I hope that this video has helped you think about the kind of calculations you need to do in order to complete your lab report.